How long would it take for a Boeing 737 to travel around the sun? So we all know the sun, but for the few of us that don't, the sun is a star. Well, let me explain. It is a hot ball of glowing gases at the heart of our solar system. Its influence extends far beyond the orbit of distant Neptune and Pluto, which by the way is not a planet. Without the sun's intense energy and heat, there would be no life on Earth. Important to remember that although it is special to us, there are billions of stars like our sun scattered across the Milky Way galaxy, all varying in size, temperature, and ultimately color. Anyway, back to our sun. Did you know that if the sun were as tall as a typical front door, the Earth would be the size of a US nickel? Or did you know that the temperature at the sun's core is about 27 million degrees Fahrenheit? Well, for those of you that didn't, now you know. Moving on. Before we start doing the math, let's get something clear. It is not possible to fly around the sun, as radiation from the sun destroys any solid object that approaches it before the object would even enter the atmosphere. If some object did survive the atmosphere, it would be so turbulent as to be incapable of supporting aerodynamics flight. The atmosphere also contains no oxygen in the form of supporting the combustion of traditional aircraft fuels. We may be able to accelerate a spacecraft which uses oxygenated fuel requiring no external supply of oxygen to orbit the sun at some altitude which we determine will permit the spacecraft and occupants to travel unharmed by the sun's radiation. However, remember, orbit is not the same as flight. Also, remember, we already have such a spacecraft. It is called Earth. It circumnavigates the sun in slightly less than 365.25 Earth days. As we orbit closer to an object, our orbital period shortens. As we orbit further away, our orbital period lengthens. The Helios 2 spacecraft passed by the sun at an altitude of around 43 million kilometers, slightly inside the orbit of Mercury, which is 60 million kilometers from the sun. Mercury has an orbital period of approximately 3 Earth months. So, if our aforementioned hypothetical spacecraft orbited the sun at that altitude, we would expect it to take about 2 months to orbit the sun. So, with that in mind, let's get back to the matter at hand. And the question was if a Boeing 737 were to in a different world. You get it? A different world, but we're actually talking about the sun. Not funny? Okay, so what I was saying was if the sun had the atmospheric and gravitational conditions of the Earth, and the Boeing 737 could take off from one point of the sun, just like on Earth, and have enough fuel for it to take one lap around the sun and get back to where it started, how long would it take? First, let's get a few conditions straight. In this case, we will take the average speed of a Boeing 737 and not the top speed, although we could do that too. The plane would travel at the same height as the average height of a Boeing plane, which in this case would be at 9,145 meters or 30,000 feet. And the weather conditions will be normal or mild. We won't give that too much power in this equation. We decided that the speed of a Boeing 737 is 453 knots, which would be 939 kilometers per hour or 521 miles per hour. But remember that in the real world, the speed could vary with altitude and temperature. The colder the air, the more efficient an engine can run. The higher the altitude, the thinner the air, which allows for planes to travel at much greater speeds. But that is also up to the engine's performance as well. So, the math. Well, we know with a quick search on Google that the diameter of the sun is 1,399,000 kilometers. Or for you Americans, it would be 864,340 miles. Now, with simple geometry, we can find the circumference of the sun. All we do is take the diameter and time that with p, and we get a circumference of 4,379,000 kilometers, or 2,720,984 miles. And then we simply divide the circumference with the speed, and we get the amount of hours it would take. In this case, we divide 4,379,000 with 839, which is the speed. And we get 5,219.308700834327 hours, which we could just divide with 24 and we get 217.47. I'm not gonna say the rest of it. Days. Cool, isn't it? That was it for today, ladies and gentlemen. If you liked the video, give us a thumbs up. If you didn't, well, I guess you know what to do. This video took such a long time to make, so I would appreciate any form of response. Otherwise, keep looking out for new videos coming soon, and have a blessed day. Peace.